Welcome back all of you. So all those things that we have been doing from the very first part, the information, the knowledge, the domain, the properties, now we have come to a part in which we'll use all those by doing simplification and transformation of functions using elementary properties that we have learned in the previous part. So this is a real marker of the understanding of you all about the chapter. So we'll start on this part and try to see what are the things that we have learnt are useful, or if they are, so how they will be implemented or how they should be implemented. So the major objective of this part has to be the understanding about the application of properties that we have learnt onto the last part. So let's start and try to find out what is our level about the understanding of the properties and the various other things that we have done in the previous parts. So let's start. Although we have seen the graphs and the other things into the inverse trigonometric functions, but properties are the most important and integral part of inverse trigonometric functions, because it helps us in dealing with questions, it helps us in understanding the core of the problem. So let's start. The property number one that we're going to have is sine inverse of x, and that is equals to x, considering the fact that I have x in the range of -1 to 1. This is a normal sine function, but what I am thinking of, that whatever is inside, first of all it must be defined. So sine inverse x is only defined when x is from -1 to 1, because from the definition of domain and range of the function we have seen that whenever x is from -1 to 1, sine inverse x is only defined at that point. Hence the definition of sine inverse x has to be taken care of because it's inside one of the functions. So the time when sine inverse x is defined, my answer for this equation will come out as x. Similarly, y is equals to sine inverse x can be written as equal to x, where x belongs to -1 to 1, y belongs to -1 to 1, and the function is aperiodic because it will not repeat itself at any given point of the domain. Moving further, cos inverse of x is equals to x only when x is from -1 to 1. This is cos, because we also know that cos inverse x as complementary to the sine is always defined from -1 to 1. Hence the function is defined with respect to multiple functions is inside that, so this must be defined. And how this is defined? This is only defined to the case when we are taking the definition of cos inverse x, and cos inverse x is only defined from -1 to 1. Hence the given function will work into its given format when x is from -1 to 1. Tan inverse x is equals to x when x belongs to R. It's a common property of the tan. We all know tan inverse x is always defined for all the real numbers, so no need not to consider or have any bit of doubt about what has to be the definition and the region where this will be defined. Sec inverse x is equals to x when x belongs to R. Similar theory, but we need to consider one more thing, that sec inverse x is defined at some point. We need to take care of that. Sec inverse x is always defined when R is from this, because I cannot have anything which will make this undefined. So I have to make sure that whatever my values of x I'm taking off, it has to be proper with the domain. Similarly, cosec inverse x is equals to x. It is opposite of the sine thing, so domain has to be in that order only. Moving further, sec inverse x, that's equals to x, and x mod of x is greater than 1. So this is what the properties will come about and give us a reflection of how multiple functions can be used in inverse trigonometric functions. There are some notes which we must cater to. Sine inverse of sine x is equals to x when x is only from -π/2 to π/2. We all know that sine is a periodic function, but we have defined a principal range for that, and we need to work only onto that format. So sine inverse of a multiple function will be equal to the same value if and only if x is in the principal range, and that is what we have defined from -π/2 to π/2. Because in this range I can completely define the function, and at the same time will have the opportunity and flexibility to get the whole values across the range without undermining the definition of so-called function. Similarly, cos inverse of cos x will be the same when x belongs to 0 to pi. Tan inverse of tan x will be the same when x belongs to minus pi by 2 to pi by 2. Just note a difference, that this guy in this minus pi by 2 and pi by 2 are not included, because once this is done, I'll have the value of tan x as undefined, because cos 90 is not defined, hence the inequality will remain over here and equality won't come. Cot inverse of cot x will be similar in terms of cos if I have to consider the values of x. Cosec inverse of cosec x is minus pi by 2 to pi by 2. The equality is not defined at the positive values. Sec inverse of sec x 0 to pi, and x is not equal to pi by 2. Moving further, there is a question which we must do. Find the value of the following sine inverse of sine 1. So first of all, I need to make sure that I am considering a function sine inverse of sine x. It is only defined x when x is from minus pi by 2 to pi by 2. I am pretty sure that 1 always lies between minus 1.57 to 1.57. So that's why the answer to this will only come out as x, and that will be equals to 1 radian. So this is how we have exactly used the property in order to find out solution to these kind of questions. Second property, cosec inverse x is equals to sine inverse 1 by x when mod of x is greater than equal to 1. So let's understand this. I am saying I have a theta onto the left hand side. So let us suppose this is theta and this is cosec inverse x. So I can say that I'll have a triangle in which cosec theta is x. Let's draw a triangle in which cosec theta is x. So this is theta, cosec theta will be this over this, and this thing will be x square minus 1, because that is how the triangle is going to come up. Now I want to write the same theta in terms of x. If I'll try to write out the same theta, theta of sine will be 1 by x. So theta will be sine inverse 1 by x. But mind you that I have started from the LHS. So LHS must be defined in order to write its equality. Hence, I can say that mod of x has to be greater than 1, which itself is the domain of cosec inverse x. And at the same point of time, I know that my sine inverse x is only defined when the value that is going inside the sine inverse ranges from minus 1 to 1. So if I'll try to solve this, I'll get the same region of x, that mod of x has to be greater than equal to 1. Then only I'll have this property satisfying. But simultaneously at the same point of time, if I'm writing it in terms of sine inverse x, I'll get the same thing, but the domain will just interfere into that. And mind you, I cannot have x as equal to 0 because x equality will make cosec inverse undefined. Hence, that cannot be the part of the domain. So these things are quite important, and the only thing which is important in inverse trigonometric ratios is the equating of the angles. Whatever is onto the left hand side and whatever is onto the right hand side, we have to equate both of them equally. Second property, sec inverse x is equals to cos inverse 1 by x when mod of x equals to and greater than 1. Similar reasoning, we need to draw a triangle, we need to equate that, and we'll get that this is nothing but this is the triangle. Sec inverse x has to be defined, so sec inverse x is defined when mod of x is greater than 1. Similar sounding this process when cosec inverse x needs to be worked upon. But as soon as we go into the cot inverse x, there is a difference. See why? Cot inverse x is the range of angles which will range from 0 to pi. If I name it as angle, it will range from 0 to pi because the range of cot is 0 to pi. But if I am converting it to tan inverse, which is something from minus pi by 2 to pi by 2, I need to do something which will help me out in order to get this range. See, I have 0 to pi by 2 into this. What do I need? I need an extra pinch of pi by 2 to pi. And how can I get that? I'll get that by adding a pi onto the given range. In minus pi by 2 to 0, if I'll add a pi, so pi by 2 to pi, this is what will come. And I know that negative values will be encountered by tan in the case if and only if whatever is inside is less than 0. So whatever is inside, if it goes less than 0, I'll use the property that pi has to be added into the angle, but when it's not equal to 0, I'll just confirm to the fact that it has been used in the inverse format only. Now, cosec inverse x and sin inverse 1 by x are identical function, but sin inverse x and cosec inverse 1 by x are not identical function, because domain of sin inverse x and cosec inverse x are not equal, because x equal to 0 is included in this part, but I cannot say that cosec inverse x also takes care of this value. It is excluded. Similarly, sec inverse x and cosec inverse 1 by x are identical function, because domain that is equated over here is quite same, but cosec inverse x and sec inverse 1 by x are not identical, because domain does not suffice to the fact. Moving on to third property. Sin inverse negative of sin value is minus of sin inverse x, because we all know that sine of minus theta is equals to minus sin theta. We are just using the hold of that property, and whatever and whenever we are doing anything in inverse trigonometric ratios, just make sure that domain is there which satisfy the equation. Anything going out of the domain will never be a part of property and never be a part of question. So whenever you are doing a question on through the ITR, just make your head straight and look whether the question is defined within the bounded limits of domain or not. Similarly, tan inverse of minus x will be equal to minus tan inverse x, and x will be considered of domain only. Similarly, cos inverse of minus x will be pi minus cos inverse x. All of us know that cos of something to the second quadrant will always lead us to the pi minus theta, because cos is negative only into the second quadrant. It's positive in first, fourth, and negative in second and third. So with the range of values of cos, which will be from 0 to pi, I know that from pi to pi it will go on to the negative range. So in order to make it positive and worth equating, I'll use pi minus cos inverse of x. Cot inverse of minus x will be pi minus cot inverse x, using the same analogy of equating the angles onto the both sides. Cosec inverse of minus x is minus cosec inverse x, considering the all out domain present there. Sec inverse of minus x is pi minus sec inverse x, altogether majorly onto the same theory of equating the range. Equate the range. I am keep on telling you continuously from time onwards, equate the range. That's what the ITR is all about. If you equate the range properly and correctly, you are a champion into the ITR. There are certain other properties which we must know of. Sin inverse x plus cos inverse x is pi by 2. This can be generalized by using a triangle, because we know that sin and cos are complementary angles. Similarly, tan and cot, and similarly cosec and sec. That is how their names have been also given up, as one of the ratios is complementary of the other. So let's add a co in front of that. This is just the basic difference. And again and again, I am using it, but well within the limits of domain. I will not go anywhere haywire if I am considering the sin inverse, cos inverse, tan inverse, cot inverse, cosec inverse, sec inverse. I'll have to work within the bounded limit of domain. So let's see. Find the value of x if 4 sin inverse x plus cos inverse x is equal to 3 pi by 4. So first of all, what will I do? I'll try to represent the cos inverse of x in terms of the property that I have just read. It's pi by 2 minus sin inverse of x. Now once I've done that, I have a linear equation in sin inverse of x, with the help of which I can find out the value, which comes out as pi by 12, and pi by 12 can be written as pi by 3 minus pi by 4. I know of all the values from this, so I can use the addition formula of sin a plus minus b, and I know its expansion, so I can directly use onto that to find out the answer. Next, in the most important properties, tan inverse of x plus y over 1 minus xy if xy is less than 1, pi plus tan inverse of x plus y over 1 minus xy, x greater than 0, y greater than 0, xy greater than 1. This again the same thing. Why there is a variation into the formula, I can just directly use theta 1 plus theta 2 in order to get towards the answer. Why is the case? Let's understand. See, theta 1 is the one which is ranging from minus pi by 2 to pi by 2, and so do theta 2. But if I'll add them up, the range that it caters becomes minus pi to pi. And if I want to write it in terms of tan, I cannot do the same thing. So what I have done, I have divided these things into three parts. One is being minus pi by 2 to pi by 2, which compels for the first part. Now there are two things left. One thing is from minus pi to minus pi by 2, and the other one is from pi by 2 to pi by 2. So I need to take care of those two ranges in which these kind of values are going to lie from this. So these two are the explanation of that, and we'll try on and see how it is done. Let's tan inverse x is equal to a. Let's suppose I've used it as an angle, and tan inverse b is this, where a and b both belong to minus pi by 2 to pi by 2. Now the standard formula of tan a plus b, tan a plus b will be tan a plus tan b, 1 over 1 minus tan a into tan b. Now using the value from this equation, I can put it over here. So a plus b can be written as tan inverse of x plus y over 1 minus xy. So tan inverse of tan alpha, where alpha is from minus pi to pi. See, this is what I have done. This range is going to be from minus pi to pi, because I am adding two angles which are ranging from minus pi by 2 to pi by 2. So tan inverse of tan alpha, where alpha is from minus pi to pi. Moving further. So tan inverse x plus tan inverse y will be something as alpha plus pi, when alpha is from minus pi by 2 minus pi by 2, because this is out of the range. I need to add alpha, then only I'll get the range. When it will just alpha, when alpha will be ranging from minus pi by 2 to pi by 2, and it will be alpha minus pi when this will be ranging from pi by 2 to pi. So this is the variation of the angles of tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y plus pi, because of the following values that I have used. When tan inverse x plus tan inverse y is ranging from minus pi to minus pi by 2, tan inverse x plus tan inverse y, normal thing, from minus pi by 2, when the summation of the angles is from minus pi by 2 to pi by 2, subtracting minus pi when the values are ranging from pi by 2 to pi. So these are the three various variations that are there in the tan inverse formula. Certain properties of that which you must learn. Tan inverse 1 plus tan inverse 2 plus tan inverse 3 is equal to pi, which means all these three are angles of a triangle, because sum of three angles of a triangle is equal to 180, and this is what it is. Tan inverse 1 plus tan inverse half plus tan inverse 1 by 3 is equal to pi by 2, another result. And tan inverse 1 plus tan inverse 2 plus tan inverse 3 over cot inverse 1, cot inverse 2 plus cot inverse 3 is equal to 2. Hence these three are quite important, and they can be directly used as an end result into some of the questions. Let's understand and make our understanding much and more firm with the question. Tan inverse 2 plus tan inverse 4. First of all, I will use the basic formula. Tan inverse 2 plus 4, it's 6 over 1 minus 8. So this is what? Tan inverse of 6 over minus 7. But what I can see that I cannot do it directly, because from the last properties I have used and seen that whenever they both are greater than 1 and the angle is coming onto the certain range, I'll have to add pi. Tan inverse 6 by minus 7. So once I'm done with that, I think from the conversion of cot inverse x, when the angle was less than 0, I could have written it as pi tan plus tan inverse 1 by x. Now I think I can write it as cot inverse of minus 7 by 6, and that what the question is demanding of. I need to write this up into the terms of cot inverse. Hence the value of lambda is equals to minus 7 by 6. So this is how I've used the various properties that I've learnt previously in order to understand the properties that we've learned till now. And after this we'll learn some more properties and their deep-rooted application for proper understanding of ITR and its other applications. Moving on to the next property, let's see what do we have. So coming further, I see that I have to find out the values of sine inverse x plus sine inverse y. Now what do I see on the right hand side? If I'll take the values range, that will be from minus pi by 2 to pi by 2 for x as well as for y also. So in that case, I'll be ending up with values which will be from minus pi to pi. The minimum value that this side will take will be minus pi, and the maximum value that it will take will be pi. So in all totality, I need to represent a total interval from minus pi to pi. Now there will be a problem, because if only I am using sine inverse of function, I'll be only ending up into the range of minus pi by 2 to pi by 2 both inclusive. So I mean there is something which is left in order to find out, and that could be found out very easily by doing a bifurcation into the formula, and that will be pi minus sine inverse x into x root over 1 minus y square plus y root over 1 minus x square, in which x is greater than 0 and x square plus y square is greater than 1. So what is this? Let's try and understand. What I am writing down an equation, that is x square plus y square equals to 1. If I look properly and eloquently into this, I'll see that this is equation of a circle. Now what do I have? I have a circle which is of unit radius, and the point onto the x axis will be 1, 0, and point onto the y axis will be minus 1, 0. The first statement says that when x is greater than 0, which means the first quadrant, and y is also greater than 0, which entices and confirms that it's absolutely the first quadrant, and the area that is enclosed into this is less than 1, which means I am strictly talking about the area which lies inside the circle. So whenever x and y are onto this range from 0 to pi by 2, I can say that the values of the sine inverse x and sine inverse y is absolutely going to be just sine inverse into x root over 1 minus y square plus y times root over 1 minus x square into the whole brackets, right? And when just x is greater than 0 and I am totally interested in the values which cater to the fact that x square plus y square is greater than 1, which means it goes outside. So I can say that the answer to that fact will be pi minus sine inverse x root over 1 minus y square plus y root over 1 minus x square. So that is how we try and understand things. So let's see how to get specifically towards the formulas that I have just said, and I will try to understand what is this. As we know that x square plus y square, if it's less than 1, then what I can say, sine inverse x plus sine inverse y is definitely going to be less than pi by 2. Now assuming the very basic thing that I am trying to explain you from the very start, if I have sine inverse x and that is equal to some angle alpha, I will take a triangle in which one angle is alpha, and value of sine alpha will become x is to 1. So this will be 1 minus x square. And similarly for y, what I have done, I have taken up an angle beta. This will be y equal y and 1, and this will be 1 minus y square. Now sine inverse x becomes alpha, sine inverse y becomes beta. Now if x square plus y square is less than 1, so what I'll have? I'll have sine square alpha plus sine square beta will be less than 1. Now if this is the case, what I can say that sine square alpha, if sine square beta is second to that side, this will become 1 minus sine square beta. Now sine square alpha is less than cos square beta. There is one equality sign which is left out over here, so this will be less than equal to. Now we know that sine and cos are the complementary angles, so as per the convenience I can write sine square alpha, which is onto the left hand side of the inequality, is less than equal to sine square pi minus beta. I have converted my cos into sine, and that is how the conversion is going to take place. From here I can say that alpha is less than equal to pi minus 2 by beta, and hence alpha plus beta will be less than equal to pi by 2. So this is what is the whole procedure of understanding that if I am taking the region which is inside the circle, right, the region which is inside the circle, what will happen to the values of alpha and beta. So this is how I have concentrated and found out the values for the case when the sum of the angles is less than pi by 2. But we also know that 0 plus sine inverse x plus sine inverse y is going to be from 0 to pi by 2 from the values that have been calculated onto the last slide, right? Calculated from last slide. Just make a note of that. And if x square plus y square is greater than 1, I can say that my answer is going to range from pi by 2 to pi sine inverse x plus sine inverse beta. The minimum value for the case when I am taking values outside the circle will be pi by 2. That will be the minimum value, and the maximum value that it is going to take, that will be pi. So these formulas should normally be used in establishing the identities, because we have just done one thing which I am stating off from the very start. Whatever was the range of values from RHS, I have just tried to put it into the LHS, or whatever be the range of values from LHS, I have just equated to the RHS. That's it, and nothing exceptional has been done in this whole chapter. Let me remind you again and again, this chapter is only about understanding of ranges and the definition, how we have drawn and made the functions. Moving further, let's solve a question. Let's see what will happen onto this. We have been given that cos inverse x plus cos inverse y plus cos inverse z is equals to pi. Now I need to find out the value for x square plus y square plus z square plus 2xyz. So what I can think of, that let's solve cos inverse x plus cos inverse y. This will be pi minus cos inverse z, right? And I think I can write it off as pi by 2 minus sin inverse x plus pi by 2 minus sin inverse y. This will become pi minus cos inverse of z. So equating further, if I'll try to write it off as pi minus pi by 2 plus sin inverse z. So 1 pi by 2 is going to cancel up with 1 pi by 2. So I'll be left out with sin inverse z plus sin inverse x plus sin inverse y, and that will be equal to just pi by 2. Now this is the relation that I have found out from the given question. Now I think I can take one sign to the opposite side, and that will be, suppose, sin inverse x plus sin inverse y. That will be pi by 2 minus sin inverse z. Now I think what I can use the formula for sin inverse x and sin inverse y into this case, and then this will become sin inverse of x root over 1 minus y square plus y times root over of 1 minus x square. And I need to find out something, that will be pi by 2 minus sin inverse z. Now this is pi by 2 minus theta. So can I say that this will be nothing but sin of pi by 2 minus sin inverse z? If you do the simplification from this point onwards by squaring onto the both sides, we'll see that we can very easily find out the value for the x square plus y square plus z square plus 2xy. It's quite easy in order to find out. So this is how these kind of questions are done. You have to understand that what is given in the question. See, we started off with 3 variables, but we knew that we need to end up with a relation onto that variables, which will be somehow looking like this: x square plus y square plus z square plus 2xyz. So my whole aim must be towards finding out a proper relation which can somehow very easily convert this into this format, and if not, I can use some of the properties in order to get towards this. I could have done it with cos inverse also, no issues, but as if we are doing the application for sin inverse, so doing it with the help of sin inverse would have been much more better for the understanding of the topic. So yes, there are more than one ways to do this question. You can start off with cos inverse, no issues probably on that. You can start off with sin inverse, no issues on that, and you can go for conversion if you want. If you are a person who is totally interested into doing questions in a complex manner, you can go for the tan inverse x by 2 conversion. No issues, you can do with that, but ultimately you will end up with a constant value that this relation will take. So it will be beneficial for you so that you can do this, and answer to this will be provided into the next part. So I hope the simplification and transformation of inverse function by the elementary methods would have been a very easy task for you. But the deal is not done yet. You'll have to look for equations, inequations, inequalities and various other multiple facets of ITF combined and gelled up with the various other topics of mathematics. And this is the area where the crux part of the questions come into JEE Mains and Advanced. So in the next part, we'll try to look for the identities which involve ITF, or the equations or inequations which involve ITF. So stay tuned for more videos in which we'll discuss all these prescribed topics.